Okay, excellent. I think this is my first time being able to pull it off almost 2 minutes from within the starting time. So I'm kind of glad that you're joining us, and we have some friends actually joining us on our YouTube channel. So thank you and welcome to today's webinar. My name is Edwin Robledo. I'm part of the Autodesk support team. I organize a lot of these webinars, the content that's going to be covered, as well as I've been lucky enough to be able to participate in many trade shows, which give me the opportunity to meet many of you in person. Well, first of all, I always like to ask, where is everybody located? Just to let you know, Jorge and myself are located here in South Florida. We were not affected by the recent storm, but it is raining quite a bit of a storm today, actually outside as well today. So we're in South Florida. Anybody from Europe? Anybody from Germany, Asia, Asia Pac, North America, South America? Love the name. Okay, our friends from Canada. Yep, excellent. Thank you very much. Oh, from India. Wow, nice. Okay. Oh, so we have more than one from Canada. Okay, so excellent. And John, you're in Texas, if I'm not mistaken. John is our resident expert when it comes to RF. So uh, we like to consult with him when we're doing some of our webinars. So I appreciate it you being here. And on our YouTube channels, we have a friend from España, Madrid, the motherland. I mean motherland if you're from Puerto Rico. Anyway, I'm just going to go ahead and go through some slides really quick. Let me just turn off the camera. That way we take away the distraction. Well, oh, let me go ahead and record this. Some people actually do like the recording, so I'll go ahead and enable recording. That way our team can go ahead and edit it and make it available on our YouTube channel, even though it becomes available when we're on our YouTube. So thank you very much, Pablo. Appreciate that. Now, so today, we're going to be covering the electrical mechanical workflow between Autodesk Eagle. And what exactly is necessary? Why is this necessary? Because in the past, there was always a need for any type of product that is smart product that combines multidisciplinary levels of engineering need to be somewhat compatible, and that has always traditional been the issue. What do I provide our mechanical engineer from my PCB that is functional and workable? In the past, we would have to do quite a bit of file conversions for that to work. And that was not easy because you're very prone to error, prone to translation mistakes, as well as have to respin your boards or the actual enclosure or the actual design multiple times until you get it right. Now, with the integration with Autodesk Eagle and Fusion PCB, that's no longer necessary because not only you're getting a rendering in 3D that is nice to view and gives you a realistic visualization of your design, gives you a lot more than that because it's functional. And part of that, I'm going to talk to you about it today when we go into fine tuning, okay, which is what I want to try to do today. So what exactly does an electromechanical workflow actually needs? As you know, almost all consumer products require multiple levels of engineering. So you need to be able to create a design that meets both the electrical and mechanical requirements of the product, all in a collaboration environment, all in one shot if possible. Be confident that they're working with the most recent version of the electrical and mechanical designs. So any type of updates that are actually being done to the electronic side versus the mechanical sides, you need to be reassured that you're always working with the latest version. That way, the appropriate adjustments are taken into account. And also, the capability of quickly responding to design changes made by members of the different teams that are working together. Now, to be able to accomplish this, we had to go through many steps. So that's where we concentrated mainly. That's what the developing team was the inspiration, at least initially. We're going beyond that. We're going a lot further than that. But initially, it was how do we create a collaboration environment between the mechanical and the electrical and the electronic engineer. That way, there's no more file conversion, no more mistakes. So we had to consider multiple workflows for this to work. So first of all, we have It's not, there's no particular order, but these are the possible workflows that are possible. So have the mechanical design in Fusion 360 dictate the shape of the PCB. And that's where I'm going to be working today quite a bit. I expect this to be a short webinar, but that is the area I'm going to be working at mainly. Now, make changes to the PCB component placements in Fusion 360. Have the capability of taking those modifications that have been accomplished in Fusion 360 and bring those into Eagle. That way I could make the appropriate adjustments for the characteristics of the PCB. In other words, I could fix the routing if necessary. I could fix my hole placements. I could fix whatever is necessary. That way I can now comply with the enclosure that is being worked on and make further edits in Eagle to update the board in Fusion 360. And that's basically what we're going to be doing today. We're going to experiencing that. If you have not seen, we've done a couple of videos about this, Jorge and myself, but today I wanted to go open up the platform in case you have any questions while we're working on this. And I'm going to try to do this from the standpoint of an ECAD guy that knows very little when it comes to the mechanical aspects. I know enough to be dangerous, but I'm visualizing this from the electronic side, okay? So PCB requirements lead the development of the enclosure. This is another workflow. The enclosure design in Fusion 360 leads the PCB design workspace outline. That's another one. Or collective project design in which ECAD, MCAD teams collaborate for optimal product designs. Those are basically the three types of different workflows that could lead to the consumer product. So it all depends who's leading the consumer product. It's led by the PCB, it's led by the mechanical enclosure, or it's a collaboration format. Okay, so let's go ahead and start with Eagle as. Okay, so as you can see on the bottom left, I have a PCB actually is leading the enclosure, while on the right-hand side, I have an example of the enclosure, actually a portion of the enclosure is being used for the PCB and taken back into the actual enclosure that already exists. This is actually a jigsaw. This is actually a sawsaw. That's what this is. So let's go ahead and work with Eagle. Okay. First of all, let me just go ahead and get my Eagle up and running. Okay, so this is the schematic that we're going to be working on. It's a schematic that I've used for some other demonstrations in the past, and it really is, it takes advantage of this whole electromechanical workflow, and you're going to see why in a minute, okay? I'm going to open up the schematic with components and a lot of connectors. And for this design, I actually use the Raspberry Pi um, enclosure. It already exists, so why create another one? So I just took advantage of the Raspberry Pi enclosure that already exists. So for my schematic, I'm going to go ahead and create my circuit board. Okay, so as you may know already, just click here. Oh, 1 second, let me do this again. Okay. So when you convert a schematic over to a circuit board in Eagle, you're going to end up with a PCB, as you could see. All the components on the left-hand side, and on the right-hand side, I have an empty PCB outline. This outline is going to be based on whatever like entitlement that you have. So if you have the standard version or the premium version or the free version, that is going to determine the size of the PCB outline. But in this case, I actually want to import a board outline, which I want to project in Fusion 360. So let's jump over the Fusion 360 now that we're done with the schematic and we want to start with the PCB. And let's go over and jump over here to Fusion 360 and take advantage of this enclosure. Now this enclosure actually has many areas in which are actually covering my view of where I actually want to put the PCB. So I'm just going to use the view to hide some of the areas of the board, as you could see. And now I just want to take this platform. The board is actually going to be sitting on the bottom here of this board right here. That's where the circuit board actually is going to be sitting down. Okay. Now the first thing you need to do is that you need to define the area where the circuit board is actually going to be sitting. The circuit board is not going to be sitting on this surface right here. It's actually going to be sitting on these pivot points that we have right here. Okay, so to be able to do that, we need to draw. The first thing you need to do is to draw a sketch. And when it comes to PCB workflow and Fusion 360, you gotta always work with a sketch, but you need to define the surface where you want that sketch to be drawn on. Since it's not going to be directly on one of the X and Y or Z um, planes, we need to define the plane. So I'm going to click here where it says construct, and I want to create an offset plane. And I want my PCB to actually be sitting on this plane right here. I could use any of these pivot points as my surface plane. I'm just going to select this one right here because this is where I want my PCB to sit on. This is where I want it on top of those pivot points right there. Okay, excellent. I'm going to go ahead and click OK. Let's see if I did that right. Now that I have defined the surface where I want my point to be, my surface for my PCB to do, I want to actually project this bottom surface. I'm going to make a projection of this bottom surface because that's basically going to be the size of my circuit board. So I'm going to go ahead and click on create. Okay, I got to activate sketch. I forgot that. I got to activate the sketch command. And the first thing the sketch command always wants is what surface are you going to be drawing it on? I actually want it on the surface that I had drawn right here. So when you activate the sketch command, the first question it's going to ask you is which surface you want it drawn. So I want to actually draw on that surface. As soon as you determine what surface it is, it goes to like a 2D view for some reason in Fusion 360. So I've defined my surface. And now what I want to do is I want to create a projection of the bottom of this surface. So I'll click on create and I'll select here project, and I'll select the projection tool here. Now I actually want to project the bottom portion of this enclosure, as you can see here. Now it's projecting everything, which is kind of neat, but I don't need these holes to be projected. There's a lot of material here that I don't need projected. So I'm just going to highlight them and you select delete to get rid of them. Because I don't need a lot of these. Like I don't need these at all, period. So I'm just clicking on them and selecting the delete button. Now also here, I don't need this outer boundary. I only need the one in the middle, this hole. So I'm going to get rid of these right here as well, because I only need the one in the center to be projected. Okay, so I'm getting rid of those. And let me just go ahead and highlight the centers, which I actually need projected. Okay. And that should take care of my circuit board. Now, as you can see, the circuit board goes all the way to the edge of the board right there. It goes all the way to the edge. So being able to fit this into this enclosure might consist in some constraint, some size constraint. So I'm just going to go ahead and make it smaller. How you do that, I'm going to go ahead and use right here where it says offsets. And I'm going to select one of the edges of the projection of the sketch projection I just created. Okay. And as you could see, it automatically goes plus 1 millimeter. I actually want to go minus 1 millimeter. I want to go smaller. I want my projection to be smaller. That way, when I put my circuit board inside the enclosure, it actually works. Now I'm going to go ahead and click OK. Okay, so you see the different, it tells you that there's a 1 millimeter offset right here. Okay, this is pretty good. I think we did well, but my holes did not get projected onto the board. I don't see them. So let's go ahead and go back and edit my, I'm still in the edit mode here, on the sketch edit mode. So let me go ahead and tell it to project, and I'm going to go ahead and project these holes. That hole, that hole, that hole, and this hole. Okay, so hopefully those now projected, and click OK. Okay, I got to do it one more time because it appears that I did not select this one here. Create, project, and I need to project this one here as well, and click OK. And click on Finish PCB. So now I have those 4 holes being projected, as we could see now. Now, based on this sketch that we just drew, I'm going to go ahead and place I'm going to create my circuit board on this area right here. So to be able to accomplish this, I'm going to click on Create and select the option PCB, Create PCB. Okay. I'm going to go ahead and place my component here. I'm sorry. I'm going to make my selection here. And as you could see, this is the offsetted body. Okay, this is the offsetted body. So this was the original projection, and here's the offset. I'm going to click here where it says Create PCB. Now here comes the tricky part that I really want you to pay attention. We should really have a concept or an idea of where is going to be the origin point of your circuit board. This is the origin that Eagle is going to be using, okay? This is the actual origin where it's going to go. Okay, now what we're going to do is I'm going to hide some aspects of the circuit board, I'm sorry, of the enclosure, because they're kind of in my way. That way I could actually see the PCB. So I'm going to hide that body. I'm just going to hide that body really quick because I actually want an Eagle. And let me bring Eagle. As you could see, Eagle is the origin point is right here, 0, 0. As you could see, this is my origin. And you always want to be working on the positive quadrant. So I want to create an origin in Fusion that will match to have the entire PCB on the positive quadrant. In Eagle, it's best you can work on a negative quadrant, but if you're using the free version or standard version, you cannot have negative coordinates or you work on any negative quadrant in Eagle. You got to always be working on the positive quadrant. Therefore, we need to define the origin. That way the origins match. So this is the origin in Eagle, and we're going to have that circuit board that we just created in Fusion 360, bring in that component with that origin there. And how do we do that? So in Fusion 360, I'm going to click here. I'm still in the PCB profile workspace, as you could see. I'm still in the PCB profile workspace. I'm going to click here, origin. I'm going to select here, and I want this to become my origin right here. Want this to become my origin. That's my origin now. As you could see, it's selected. Now, yes, if you had a more complex board out enclosure, there are instances where you need to tell it where is the X orientation. You may have an enclosure in which you have Z involved in it. So you've drawn it in Z, so it gets confusion where the PCB is actually sitting. So I want to reorient. This is only for PCB profile. This has nothing to do with Fusion 360. This is only for Eagle purposes, and you do this in Fusion. I'm going to tell it I want to reorient my x-axis, and I want this bottom portion here to be my x-axis in Eagle. Okay, and as you could see, that way this is my origin, and that other portion will be, and this will be my x-axis, which is going to meet this x-axis here. That's all that is. I'll go ahead and click OK. And our circuit board has been created. It's kind of nice because it automatically, since I projected the holes for the divot points where the screws are going to be screwed in, they already are there, which makes it a lot easier to work with as well. Okay, so we could turn that back on. So now we're looking pretty good so far. Let's go ahead and save what we've done so far. Go ahead and save. Okay. And what we're going to do now is that we're going to take this PCB outline and import it into Eagle. Absolutely no file conversions at all. Okay. Just make sure I know which one is called. This is called Fine Tune, is the name of this project. That way I could find it in Eagle. So let's go into Eagle. Let's click on the Fusion 360 here. Yeah, I want to link to an if I was pushing this project to a brand new Eagle project, in other words, usually that would mean that Eagle is leading the design enclosure, but in this essence, the enclosure is leading the design. So I'm going to go ahead and bring in that board outline. So I'm going to link to an existing 360 design. It's loading. As you can see, it's loading all my projects that I have. And here's my fine tune project. And under fine tune, here's my piece. Here's my circuit board. This is PCB. You see this name here? That's PCB1. Basically, let me bring you here. That's this PCB right here, as you can see. That's that PCB. That's that PCB here. PCB1, as you could see there. Okay, so I want to bring that up. That way you understand where that PCB1 comes from. I'm going to go ahead and bring that into Eagle. So I'm going to pull from Fusion. Oh, a lot of more people have joined us from the YouTube channel. Just want to welcome you for joining us today. And if you have some time, we'll love to know where you're from. You could just tell us where you're located. It would be greatly appreciated. Okay. We'll go close. And now here we have the board outline. Remember, I had told you that I was going to use the bottom left corner of the outline as my origin and reorient my x-axis. So now we have a really good looking board that has the x-axis exactly where it's at. Okay. So there we go. It was that easy. It's actually that simple to do. Now I'm going to just, I'm not going to really pay a lot of attention for my component placement for speed purposes. So I'm just going to start grabbing some of these parts and put them in here as reference. This is my RJ45, and I know it goes somewhere around here. I know my RJ45s go around there somewhere. And here are my USBs. I know these guys go around here somewhere. You go around there somewhere. Doesn't really matter. I'm going to put this one here as well. And then I'll go ahead and move my micro USB. All right, I'll move this guy right there somewhere. And I'll take my HDMI and put it over here somewhere, or less. Find the origin of this. My selection filter, I only want to be selecting devices. That way it no longer gets confused. Where's the origin of this part? I have that layer turned off. No, it's turned on. Goes somewhere around there. And I'm using this based on what I saw in Fusion, which, as you could see, you'll be able to see that those are connectors on the left-hand side right there. And then I got my other connectors right here as well. Okay, so I'm just using it based on that. Okay, it's kind of a rough draft, and I'll just grab some more of these components and just put them over here, little by little. I'm not very careful with my placement. I don't plan to route this or anything like that. That's not the idea today. Just run rat's nest and save what we've done so far. Okay. Now that we've accomplished this so far, I'm going to go ahead and push this design over the Fusion. That way we could get a kind of a realistic idea of what our circuit board looks like with the components already on it. So let's click on Fusion. And I'm going to click on Push to Fusion 360 right here. The green check marks alert me that those components have 3D models assigned to them. If you have not seen those videos in the past, we have multiple videos that teach you exactly how do you assign 3D models to your footprints. Okay, so I'm going to push this over the Fusion 360. And I'm just going to take a quick look at what they have here. Are you able to answer this? Yes, to answer to Fox, it would be better to send me an email address. Send me an email on your concerns that you're having between Eagle and Fusion 360. You could contact us at support.eagle@autodesk.com, because it could be support.eagle@autodesk.com, because it could be an isolated incident, and it's in this type of public forum. It's kind of difficult to address that. So now that I've sent my PCB over to Fusion 360, I'll get an alert in behalf of Eagle saying that my board has been successfully pushed to Fusion 360. I'll go ahead and click OK. And let's take a look at what happens in our board. Now here you got to be careful. As you could see, it looks exactly the same. Okay. The components, we don't see the components yet. It's because we need to refresh our project. That way we could get the version of the project with the components actually on the circuit board. I'm going to go ahead and expand here, right here, and you'll see that you'll get data in this folder has been updated. The data that had been updated is the one that I pushed from Eagle over the Fusion 360. So every time you do this push, you got to do a refresh here. I'm going to go ahead and close the original project that I have in Fusion 360, and I'm going to go ahead and load this here. Okay, here we go. It's the exact same. So we had an enclosure. We projected the surface of the enclosure on one of the pivot points. Based on that, we kind of created a board outline, really easy. And in Eagle, we took and placed those components on that and push over the Fusion. And as you could see here, we have a completed board. So far, I have not had to do absolutely no type of file conversions. I did need to make sure that my components did have 3D models, and I done that earlier already, okay? And that's really easily done in Eagle. If you have any questions and we have time at the end, I'll go ahead and try to address those as well. As you can see, we move our parts. Now, you notice that a lot of my parts are totally whacked. They're totally out of line. In other words, they're not really truly where they need to be. They're totally offset. Like this component here, and the micro USB is totally offset. They just won't work like that. So what could you do? Well, actually, in Fusion 360, you could actually move the parts. And when you move the parts in Fusion, in Eagle, you'll get an update letting you know that there's some new parts actually being addressed. There's been changes or modifications done to the circuit board in Fusion, and that you need to update in Eagle. Okay, so let's start that. Well, as you can see, you always have a timeline. You should always be working on a timeline in Fusion 360, or a history right here. Here is the portion where we actually created the PCB. What I'm going to do is I'm going to edit that portion of the timeline, because we will get an additional option where it says I could actually move components. I got that option here. This option actually allows you to flip components from one layer to the bottom layer. It actually will flip them the same way you would do mirror in Eagle, to flip components from the top layer to the bottom layer. That's what this one does right here. It actually flips it from the top or to the bottom. Here I'm going to actually just using the move command. Okay, so now it's asking me which component I wish to move. I'm going to select the micro USB. As you can see, it's slightly off there. So I'll do this really quick. You could always fine tune it. Okay, as I go, it goes -1. I think I'm -2 and too far, so I'm just going to go 1.25. And at 5, it's actually pretty good right there. As you could see, we have absolutely no collisions there at all. So it's looking good. So I'm going to leave it at that at minus 1.5. You can see, and the component is slightly off the board a little bit. Let's move it a little bit this way. It's slightly off the board. So I'm just going to go ahead and move it in a little bit. That way it's on the edge of the board right there. Okay, as we can see, I'm just moving it in a tad. That way it's actually where it's to be sitting right there. Okay, so let's go ahead and move on to another part. Let's take care of this HDMI connector. As you can see, it's almost right there. Let's go ahead and move this one right here. And I'll start moving it this way a little bit. This is going to be a positive movement at 0.5, and actually looks really good right there, to be honest with you. As you could see, it looks really good right there. Okay, this one is totally off. So let's go here. These are things that you would have to be going back and forth between between the mechanical engineer and the electrical engineer to actually be able to accomplish a lot of this exact placement. So let's go 3.1 right there. Let's go 2. Okay, that looks pretty good right there, as you could see. And you know what? I think I'm going to pull this one out just a tad more, as we did earlier with the other component. I'm just going to pull this one out just a tad more. That way this barrel is a bit closer to the enclosure itself. So I'll just go ahead and move this part really quick. Just move it out just a tad more right there. I don't want to move it out too much. Right there, that should be fine. And it's still sitting on the PCB. Shouldn't be a problem at all. I need to move these resistors out of there. Since I was not really paying much attention to this, and I'll move these down, this down, and I'll take this component. And I'll move this part here. Just move it down a little bit. Make sure it's not. Okay, perfect. Okay, now don't worry that you see that the leads stay behind. These are the PCB leads. Once we update an Eagle and we go back to Fusion 360, this will all automatically get fixed. So don't worry about it. Do all the movements that you need to do to fine tune this component. Okay, so don't worry about any of that. Okay, there we go. Falling a little behind. Sorry, I don't know why it's dragging a little bit. 3.2. Okay. And those I'm going to fine tune from the top, but I want to do them at the same time. Okay. So here I go, and I move these. Okay. Now let's take a look at it. I'm going to turn off the enclosure one more time because I actually want to take a look at this component. I mean, there's parts of it I'm going to actually turn off. I want to take a look at from the top how it looks like. One of these days I'll get involved in a 3D a 3D mouse, but so far I don't have one. I work what we have. So as you could see, these this should actually be sitting at not there. They should be sitting just a little bit more on the edge of the board. So I just move that easily real quick here. So I just move it this way, yes, a little bit. That's too much. So I just want to go maybe 0.1. That should be perfect right there. That's perfect right there. And let me move this one as well as 0.1. This one right here. Okay, so it's moving it in the wrong direction. Sorry about that. I want to move it in this direction. Right there. Okay, so that should find that works really well with all my components. So let's go ahead and let's see what happens now. I'm gonna go ahead and save this. I'll click on Finish PCB to finish what we've worked on so far. As you can see, my leads still are kind of like totally off. They're not all the way on position as of yet, but we'll take care of that now. So now I'm going to go ahead and say what we've done. Click OK. Now let's go to Eagle and update this. You're going to notice that when I do an update, all these component positions are going to now relocate according to the modifications I've done in Fusion 360. You see it in red here. And red means that there's modifications done in Fusion, but Eagle has not caught up as of yet. Okay, so I'm just going to go ahead and click on Pull from Fusion. And the nice thing is, as you could see, when I saved it, I made a note. I called it Fine Tune Connector Placement. It's really important that you use this notation because it really does a really good job of being able to have that flow between the mechanical guy and the E guy. That way you guys don't have to be calling each other, emailing each other what changes were done. So you could make this as long as you want here as well. So I'm going to go ahead and pull from Fusion 360 the changes that were done. And you'll notice these components actually move. Actually, I just noticed that there's a connect. I see one out here, which I need to move in. You'll notice these resistors are going to move down here, depending what I did, and they're there. And this component move, I need to put this, click close. And I'll go here. Okay, excellent. So let's say what we did. Now you could go ahead and start routing this board if you want to. Now, because of purposes of time, I want to make this a little bit faster. So I'm not going to get into any of the routing purposes yet. But as you could see, the projection of the enclosure did actually have a cutout, which actually will make it inhibit a little bit the routing of my micro USB. So actually, I could modify this outline in Fusion 360 and update it in Eagle as well. So let's go ahead and move over to, let's push what we've done to Fusion 360. Let's go ahead and push it. I'll get to your question in a few Nibalas, okay? I'll get to everybody's question towards the end, but go ahead and keep on placing them on the chat, and I'll do my best to cover them all at the end. So that while this is syncing up, no, there is no way of putting a logo in Fusion for it to appear in Eagle. No, there's no way. The easiest way of putting logos in Eagle is by importing bitmap files, and I strongly recommend that the logo is in 2 colors only, because the way Eagle imports bitmap files, every color is a layer. So if you have like 64 shades of gray or something like that, it's going to use 64 layers to create the logo. It's best to use just a 2-color bitmap file is best. Okay, So let's go ahead and it already finished pushing over the Fusion 360. Let's go ahead and refresh. Here, as you can see, you get the refresh rate. You get the refresh notation. Let's load the new one as well. Okay. And as you could see, it automatically fixed all of the lead spacing, not the lead spacing, but the leads on the circuit board itself. As you can see, everything is now back to where you're expected it to be. The nice thing is that in Fusion recognizes an eagle when you create slots in the milling layer. They're actually respected by Fusion 360, which is actually really, really sweet. Now, I just want to make a small modification to this board outline. That way it gives me more space to route this guy right here that I have right here. And the way you accomplish that is actually pretty simple. Let me see if I can pull it off really quick. So what I'm going to do is I'm going to pull my timeline to before the PCB. I need to do that before the PCB, as you can see there. Then I'm going to go ahead and I'm going to draw. I'm going to create a sketch, which is going to be on this plane. Make sure that I select the correct plane. I'm going to edit the sketch. Edit the sketch. And I'm going to draw a line from this point here. I'm just going to draw a straight line right here. Okay. And now I'm going to trim this portion there, and this portion there. Okay. So now the circuit board is going to, the idea is for it to go up to this line here, giving me more space on the connector here. Okay. So click on Finish Sketch. Okay. I'll move the timeline back. That way I get the PCB. Okay. But so now here's the tricky part. And you may ask me some questions about this, and I've done a few YouTube videos on this already. Now, here I have to edit the PCB. Okay. We have to see the PCB status. See, the PCB that is here is the board outline that Eagle pushed to Fusion the last time we pushed to Fusion. Now we need to update to use the new one that we just edited. And you do that by clicking, going to the PCB environment. Again, by editing the PCB environment that you already created. And you're going to click here on PCB status. And you're going to select from the Eagle PCB, which was the original one. You want to switch to the board shape from Fusion 360. Okay, now that gives us that portion that we have here. And that gives that portion. It's in brown, and that brownness means that there needs to be an update between the outline in Eagle and the outline in Fusion. That's all that means. Let's finish what we've done so far. Let's save what we've done so far. Let's go over to Eagle. Pull from Fusion. As you can see, it turned red automatically, letting me know that there's changes in Fusion, that it wants to update Eagle. There it is, PCB outline, edit PCB outline for micro USB, which is right here. I'll click on pull. And the reason I did have that space was the projection from the surface had that cutout. It was just it was a natural, because of the back door of the Raspberry Pi enclosure has that locking mechanism, but that didn't really affect the PCB itself. That's why I did have the real estate space. Now, as you could see, the space between this space actually has reduced quite a bit because it has the edit. Now I have a clear shot to route my micro USB as well. Now just to finish the cycle, I'm going to go ahead and push the Fusion 360, and I'll let that run. So I have a question in regards of making notations on the circuit board in Fusion 360 to let the mechanical engineer have an idea where to place components. No, we don't really have a way of doing that yes of yet, not in Fusion. So the information in Fusion when it comes to moving components as well as designing board outlines is all kind of the information that it goes between Fusion and Eagle. I don't have a way of going the other way as of yet. Now, I did see somebody make actually a pretty nice board outline that had a lot of LEDs. It was a star. It had a whole bunch of LEDs, and what he did was that he made patterns in Fusion 360 as holes. He made hole patterns. Then, as those hole patterns, when he brought that into Eagle, those are all appeared besides the board outline. All those holes showed up as a pattern. And in Eagle, he basically put his LEDs there and deleted the whole pattern and put LEDs, and then Eagle and then Fusion just caught up with that as well. So I've seen that done. But the concept of putting some sort of a notation on the actual circuit board in Fusion, that way the ECAD guy can get that is actually something that they're actually working on as we speak as well. Okay, so now we have let's go back to Fusion. Let's refresh what we have so far. Let's load this up. And there we have the new board outline with the with the proper spacing that we have. And of course, this component, there's a lot of placement here. We have our holes for our screws. I don't think this would be a problem here. This would work just fine. That shouldn't be an issue. And now we've just taken advantage of an existing enclosure and be able to fine tune our connector placement if necessary. Now, this is actually all the content I actually wanted to cover today. I'll go ahead and answer any questions. Let me see if I can see any questions from our friends from YouTube. I use Corel Draw vectorizer to turn the bitmap into a vector outline and then save that as a DXF. Yeah, so Eagle does have a DXF import tool, and you could import that DXF file into maybe one of the silkscreen layers or documentation layers, which you could then add, make it part of your Gerber file. So yeah, that works really well. You could use DXF as well. Actually, just to let you know, in Fusion 360, you could actually do a 2D on DXF and export that as a DXF and do it that way as well. But you cannot do it on the PCB itself. Okay, that would be a totally brand new drawing with your logo. Export that in DXF and then import that into Fusion 360. Um, um, okay, so if you Google for bitmaps to DXF and Inkscape, several people have to turn. Yeah, yeah. There's actually, and if I'm not mistaken, if I'm not mistaken, I think SparkFun had something similar to that as well. I think SparkFun had done some sort of a, not sure if it was a conversion or you could write letters or convert logos. You just check the SparkFun site. SparkFun has always some of the great tutorials, and if and I remember years ago they had a really nice one to take from images to bitmap. It worked really well. Um, yeah, and Nate, yeah, Nate does a great job with Eagle. They have actually, if you as you, I don't know if you should know already if you're Eagle user, you know you could access the Eagle libraries by SparkFun directly for the managed library. And there's one of the libraries that basically consists of logos and annotations. So like radioactive stuff and different symbols that they have created. So that's actually one of the libraries that they have in Eagle. Um, I don't. If you need help accessing managed libraries, send me an email. But if you're here, there's a really good chance you already know how to do that. Okay. Okay, so I already answered that. Let me see if there's anything on Q&A. I don't currently have that active right now, so let me just enable that really quick. Okay, so I don't see nothing on Q&A. Oh wow, the room got really full on YouTube. I had not noticed that. Thank you everybody for joining us. Wow, that's great. That's a really nice crowd. That is awesome. So let me see if there's anything in the history here. Hey Lourdes, if you're still with us, just let me know if I need to jump in any conversation that I missed, if you don't mind. Um, is that it's really inefficient because it uses lines instead of polygons. It is great if it was only an overlay, then converted into lines. And when you export Gerbers, okay, yeah, I understand what you mean, Balas, and you're absolutely good. So the nice thing of using DXF is as long as it's I don't know if many of you know about this, but if it's an enclosed shaped, so let's say you bring in a DXF file into Eagle and they're only outlines, which is what always happens. They're always outlines. Well, in Eagle, there's a new command called polygonize that will now take any shape and create a polygon out of it. And that's how we've been using lately. Take complex DXF board outlines, or not necessarily board outlines, but complex DXF files in the Eagle, and being able to fill them in is by using the polygonize command. So don't forget to look into, you could always type the command help space polygonize. That way you could see, that way you could fill in, you could easily fill those in really easily. Let me see if I could create one really quick in Eagle. I'll show you because it's really simple to use. So let me say, let me just draw a shape out line and I'll leave it on, let's say I do it on the name layer, for example. So I could draw a shape really quick here. As long as an enclosed shape, you could just right click. Give me a second, see what's going on. Oh, I know what's going on. I gotta reset this. My inspection filter. Okay. So I could right click and say convert to polygon. I could either copy it or replace it. In this instance, I'm just gonna select copy it, and I'm gonna tell it to do the on the top layer and select OK. And then now when I run Ratsness, in this case, because I did it on the Huanga, it's filled in. So that's how you use the polygonize command. So when you bring in DXF files, as long as it's an enclosed contour, you could just right click it, tell it that you want to polygonize. It doesn't have to be the top layer. I just use the top layer as an example. It could be any layer. If it's a non-copper layer, it will automatically get filled in. So that's just one easy way of taking out, DXF files, especially if it's logos and you want to fill them in. It's one easy way to go about it. Oh, happy birthday, Ron. Somebody's birthday today. Hey, happy birthday, Ron. That's awesome. Glad that you're here. Thank you for joining us, Ron. Really appreciate it. It's awesome for you being here. Okay. Okay. So I don't see any other questions. I wanted to that's basically the essence of what I wanted to do today, was to show you how to take advantage of this workflow and being able to fine tune those connectors instead of having to really um, try to guess it in Eagle itself. That way you could just go straight into Fusion and just move those connectors or fine tune those components. And I strongly always advise that you do this before you actually route the board. But if you can't, don't worry about it. If it's already a routed board, please remember that on the latest version of Eagle, we have now a new command called reroute. What the reroute command does is that it actually, when you move those parts, any components that are connected to the component that was moved, it will reroute everything. It does what we call is basically a quick route optimizer, and it will just reroute all of the everything that's connected to that component that was moved. Either it was moved in Eagle or it was moved in Fusion. You could use it either way. But we made this mainly for our Fusion Eagle users. That way, because since you're moving parts often in Fusion and it kind of looks like a spaghetti, in Eagle, it's kind of ugly. It looks really ugly. That way you could just reroute it and have that rerouted easily there as well. Okay, excellent. Well, thank you, Ron. I appreciate it. Hey, Seth, your comments are greatly appreciated. I really like it a lot. Thank you so much. After the polygon process, well, if it's on the top layer, yes, there is basically. So if you click on the here on this polygon command here, and there is a way of actually it's on the rip up command. I sorry about that. Here's a rip up command, and it rips up the polygons as you can see here. It puts it back in its outline form. You should be able to grab any of the corners and move it out. Yeah, as you could see. So yeah, you can resize polygons if necessary. It's best to do it always on their outline mode. Okay. So what I did is I click on the rip up command and I selected the option rip up polygons. There's a command line for that as well, which you could use as well if you wanted to. Excellent. Well, everybody have a great day. Thank you for joining me. It's always been a pleasure. Hey, John, thank you for the comments and thanks for your presence. Always appreciated. We'll be back. I think it's next week. Lourdes, you confirm. And we're going to be hosting a webinar, which Jorge and I are still trying to figure it out. It's going to be 30 tips in 30 minutes. And we have a lot of collaboration by a lot of our Eagle experts. They're giving us ideas, and we're hoping to be able to pull that off. We always are on time with our webinar. So when we promise you 30 minutes, we always do 30 minutes. Someday we will, but we try our best. Anyway, thank you everybody for joining me. It's been a pleasure and have a great day. Thank you. Thank you, sir. Appreciate the comments. Cheers. Bye. Bye, everybody. Lourdes, thank you very much. Greatly appreciate it.